In this video, I'll be discussing exposure controls in 3ds Max. I'll be using 3ds Max Design 2010 for this video. I'll also be using the Mental Ray renderer. Even though I'm using the latest version of 3ds Max, the information that I provide here will be applicable to previous versions of 3ds Max as well. Exposure control is a tone mapping process that adjusts the output levels and color range of a rendering. You can assign exposure control by going to Rendering, Exposure Control, and then you have an option here, a roll down box of exposure control and the different options for exposure controls that 3ds Max offers. What I want to take a look at is just some of the benefits to using exposure control here in 3ds Max Design 2010. In the scene that I've set up, I have two photometric lights here. I have one that is a photometric spotlight and one over here on the right of the objects that's a photometric light that is using an IES profile. Now I've assigned the IES profile here to demonstrate that what you want to do when you're rendering a scene and you're wanting realistic real-world values is if you use an IES profile that comes from a lighting manufacturer, you don't want to go in and start adjusting the intensity, the candela value, because that's already preset from the lighting manufacturer for that specific light that you've downloaded this IES data for. So when you go in and you alter this data, you're altering the real-world reaction or real-world results that you'll get from that light data. So naturally you would want to avoid doing that. Instead, if you want to adjust the brightness of the scene, it's best to use the exposure controls. I say it's best to use that. You don't have to use the exposure controls inside 3ds Max, especially if you're rendering out to like a floating point format such as an HDR or an EXR file format in 32-bit. You may want to apply your tone mapping in a post application such as Nuke or Toxic, some of those compositing programs, even Photoshop if it's like for a still frame or something like that. So I'm not saying that it's required that you use exposure control, but for most of us that render out using the exposure control, just especially for like the architectural world, it's generally a good idea to use the exposure control. And in 2010 we have these new hardware shading option for the viewport. Now as I showed before, in this particular scene under the exposure control, I'm not using exposure control. So when I hit render, you would expect something like this to come out. However, when I hit render, as you can see in that preview from the previous render, it actually looks nothing like the viewport here. And I'll just pause this video and let this complete rendering here. So as you can see from the completed render, we look nothing like the viewport here. So that's kind of a drawback in that if you're going through and setting up the scene, you've got to constantly render the scene in order to see what's going on, what does it look like. In 2010, with the viewport shading, what you can do is benefit to using exposure control is that you will see what it actually looks like your output. So if I just scroll down here, and since I'm using Mental Ray, I can either use the logarithmic exposure control or the photographic exposure control. This pseudo color exposure control also works in Mental Ray, but I'll talk about that later. For right now, what I want to look at is the photographic exposure control. And when I enable that, you can immediately see that here in the viewport things lighten up a fair amount. And also the colors have changed just a little bit. So looking at the previous render, let me pull this over to the side, make a duplicate copy, and I'll put on hardware shading in the viewport of 2010. Now if I pull up the exposure control again, and I'm just going to use the shortcut key here, which is 8, and just take a look at some of the settings here. Again, you have this render preview section here that if you wanted to get a render preview and adjust the settings here in this option, you can do that. However, you'll have to render the scene first, so you click that and you can see it going through rendering here, and then it puts the small thumbnail up here in this small box. The problem with this is that it's not very user-friendly, and that, well, this is all that you can see. If you wanted to zoom in and see more here, you don't really have that option. So it's okay for adjustments. As you can see, once I turn this, you can see the changes happening there, but it's not really friendly in that it's just such a small thumbnail image. It doesn't give you much detail. And of course, you have to have this active in order for the exposure control to work in your scene. So obviously that's what the active switch here does. If you want the exposure control to work on your background maps, or to affect your background and environment maps, you can check this. Quick note about this option: this option does not work with Mental Ray and previous versions of 3ds Max. This is only functioning in 2010 and newer, I suppose. So if you use this in 2009 or 2008, it won't really make any difference in your scenes. But that's only if you're using Mental Ray. So on the photographic exposure control options here, you have some presets that you can use that are really good starting points. These presets aren't meant to be universal, in that if you have an indoor scene lit by the daylight, that's the only settings that you can use. Think of this as merely a starting point, because you know, every room has a different amount of light in it. The windows are different sizes in every room, from house to house or building to building. The materials in rooms vary. Some may absorb more light, some may reflect more light. So it's really impossible to come up with a preset that works for every particular scene. So again, just think of these presets as starting points. You may get lucky and it be perfect for the scene that you have. However, if you use like this indoor daylight and it still looks a little bit dark or maybe a little bit bright, you can adjust the settings from there. But again, think of it as a starting point. Now with the photographic exposure control, you have two ways to control the brightness of the scene. One, and probably the simplest, is this EV value, exposure value. Higher values make the scene darker or less exposed, whereas lower values obviously overexpose the image. As you can see in that render preview, if I close this down, you can also see the same thing happening in the viewports here. Again, this is a 2010 only feature, this hardware shading in the viewports, which again, I can see a lot more detail here than I can in this small little thumbnail. The difference between these two is that this is not calculating indirect illumination, where this did. This actually, you made a render here to go in this thumbnail. So if there were indirect illumination in this scene, which I don't believe there is, let me just check. No, I'm not using any indirect illumination, but if this scene did use indirect illumination, there would be a subtle difference between these two, in that naturally you're not calculating indirect light in the viewport here in real time. That has to be calculated. Now, if you're more familiar with the world of photography, then you can use the photographic exposure option here. And this is useful for, like I said, if you are familiar with photography. This can also help you photo match, do some photo matching of your scenes to a background plate. If you knew the shutter speed that you used and the aperture or the film speed, if you know this data, then you can get pretty close to doing some photo matching. So to adjust this is your shutter speed, obviously, and a slower shutter speed will let in more light. So if I decrease that, you can see we're getting blown out here, whereas a faster shutter speed will not allow as much light into the camera. So let me just put this back at the default setting. And also, if you noticed, as I changed that, the EV value here is also increasing. These are linked together, but it's not actually changing. Obviously, I'm not using this. I just wanted to point out that the values are linked together. So it can actually help you learn a little bit about photography if you use this EV value, because as you know, higher is darker, lower is a brighter scene. So as you come in and you learn, okay, well I kind of like, for let's say for a daylight scene, if I wanted to use something like an EV value of 14 and I had a mental ray sun and sky set up, I could actually probably go out with my camera and on a similar lighting situation in the real world and use these values, this aperture of 8, film speed of 100, to get a similar result as I would with that particular scene. So let me just switch back here, and again let me lower this back down to what it was. And the f-stop also changes the brightness of the scenes here. Higher values, as you can see, will decrease the brightness of the scene, whereas a lower value gives you more brightness, because this is simulating, as the tooltip here says, the lens aperture. Now as you can see, since these kind of do the same thing, it can get rather confusing if you don't have that photographic background to know what these values do. So that's again why I say if you don't have that photographic background, it's probably best to stick with the EV value rather than tinker with these that can affect each other and sort of do the same thing. The ISO speed here is affects in the world of photography. This is the sensitivity of the film. Higher values make the film more susceptible to light. So as you can see, it would make your scene brighter. And on my camera I have certain presets for this, like 100, 200, and like 400 ISO, 3200 ISO, things like that. So again, if you have your own camera, you may want to just plug in some of the values that you use when you're out taking pictures. You can use some of the values from your photographs to help match up your 3D scenes with what you would expect in the real world. So I'm just going to switch back to the EV value here and set this for something like 6 maybe. So the next section here for image control, really it allows you to fine-tune what the image looks like here. For example, the highlights and burn, if I increase that, you notice I get more burn, more blown out areas here. If I set that back to 0, then it kind of clamps everything and doesn't allow any burnt areas in the image here. And let me just give this a render. So from that you can see how it's basically clamped all of those overbright areas. Now likewise, if I go back and set this to something like 0.75 and render this scene, what that's going to do is create these overblown highlights, just to allow more tonal range in these highlights, if you will. So now I have these overbright, overexposed areas, and since I am using a 32-bit frame buffer, in my settings here, in my render settings, I'm using a 32-bit floating point frame buffer. These values actually exceed 1.0 for a real world value. As you can see, this has the RGB value, and the real world scale is 3.8, 5.1, and 8.1 on these overbright areas. So that's not clamping those hot spots anymore. It's actually letting it go beyond 1 and become overbright. Okay, I'm just going to set that back to like 0.15. For midtones, as you would expect, that's controls the mid-tone range of the image here. If I decrease this value, what it's going to do is provide more contrast to the scene. Let me just bring this down to, let's say, 0.4 and render that. So if I wanted more contrast in my scenes, I can decrease the mid-tone values, and as you can see, that provides a lot more contrast. Likewise, if I increase that, I'm actually washing out a lot of the contrast in the scene. So by increasing that beyond 1, what I'm doing is, as you can tell, I don't have as much color here in the mid-tones of the image as I did. Also, it's more washed out looking. So a value for that is 1 or maybe less. I don't think I've ever gone beyond 1 with that, because you lose a fair amount of the color information. So I normally use a value between 0.75 and 1 for that. The shadow option here, a higher value increases the depth of the shadows, whereas a lower value decreases that shadow depth. So let me just set this down to 0 and give this a quick render. And what I'll do, just so that we can compare this, is drop this image into the RAM player. Let me just cut off these options here at the bottom of the frame buffer here, and go to rendering and RAM player, and I'm going to load this into channel B and slide this over to my other monitor. And then I'll just increase shadows to 1, and you can see that happening here in the viewport as well. As I increase and decrease that, it'll probably be a little bit easier to see in an actual render though, so I'm going to go ahead and render this out. Alright, now I'll just bring the RAM player back over and load the new image, or the new render, here in, and you can see the difference between the increased black value or shadow value here, where I've increased it, and where it's set to 0. I find this effect, even though it looks kind of dramatic here, it's more of a subtle effect in your actual renders, especially when you have global illumination or some form of indirect illumination in the scene. It's really kind of a subtle effect. Okay, let me just set that back to something like 0.25. Color saturation. The default value for this is 1.0. And what this does is you can decrease the amount of color in the render, or you can increase the amount of color. If I increase that, the maximum point of 5, you can definitely see something going on here in the viewport, as well as up here in this preview render, how the colors are far more saturated. Where if I decrease that to 0, you can actually get like a black and white grayscale render out of your images. So again, the default value for that is 1.0. And let me just turn that down to 0 and render this. So as you can see from this render, there's no color here. So I wanted to show that because it's kind of a neat way. If you wanted to render out a black and white image, you could do that by just decreasing that color saturation to 0. Likewise, if you need more color, you'll exceed 1.0. You can increase that up to whatever suits the scene that you're, or the look that you're after. And again, the default value for that is 1.0. The white point value, this is a very handy feature to have. The white point value allows you to balance the color, or obviously this white point, the Kelvin color of your scene. And where this is useful is in this exact type setup where I'm using photometric lights. Let me just move this out of the way here, where I'm using photometric lights, and I have entered a Kelvin value for this light source, as well as this one. I've entered in a Kelvin value of 9,000. For the light source that's using that IES profile, I'm using more of an incandescent setting of 2800. Incandescent lights can go between 2600 and 3200, I believe is the range there for those. So if you specify a Kelvin value, or you know the color value in Kelvin that you're using, what you can do is balance this white point. And if both of these lights were using the same value, for example, if I set this to, what was that, 2800, if I come in and set this light source for 2800 as well, and the default value for the white point is 6500. So let me just set that to 65 and give this a render. What you see by using this value of Kelvin value, the default value of 6500, that's almost white, so that's kind of a neutral Kelvin value to use there. And by using that neutral color, you see the actual color of the light sources here. 2800 Kelvin, you can see it's kind of a yellowish pinkish color, and that's what you're seeing here in the actual render. The usefulness in that is that in the world of photography, you balance that Kelvin setting. And one of the neat things, some of the nicest photographs that I've seen are things where the sun has just set, and you set your exposure control on your camera for a daylight value, let's say 5400 Kelvin or 6500, whatever you wanted it to set to. And what happens is you get this nice rich blue from the sky, but you also see the true color of the incandescent lighting inside of houses or buildings. And so it gives you a nice contrast between warm and cool colors. One of the videos that I made here is for an architectural exterior night rendering scene, and I used this principle in the rendering that I made for that scene. And here you can see using that kind of a daylight Kelvin value, I get this nice color from the sky, but I also get the warmness of that incandescent lighting that I use for this scene. So that's just a way for you to balance the colors in the scene, an easy way. So now that I know that both of the lights in the scene are using a Kelvin value of 2800, if I didn't want to see any of this color, if I wanted it more neutral, what I could do instead of changing the Kelvin value here is on my exposure control I would just set that to 2800. And what that's going to do is eliminate or match the color of the exposure control to this Kelvin. So instead of seeing the warm colors here, what I'll have is basically a white light source is the way that this will appear. So as you can see, that looks more balanced as towards the white value or a neutral color. Now as I increase this, the light becomes more on the warm side, because once this white point is greater than the actual white point setting or the Kelvin setting on the lights, the image will appear warm. However, at 2800 it appears neutral. Now if I set my white point lower than the actual Kelvin setting on the light, they become cooler, as you can see. So if you wanted to balance that between warm and cool, you can adjust your white point. If I wanted to do that with particular lights, for example, let's make one light warm and one light cool. And to do that, what I would do is set, let's say for this spotlight, I'll make the Kelvin, let's say 3800. And then for the photometric light that's using the IES profile, I'll make this 3200. So I have a range of 3800 and 3200. Now if I adjust my exposure control somewhere between those two values, let's say 3350, what will happen is I will have some warm light from one light and some cool color from another light. So as you can see, I have a warmer color from this light source and a little bit of a cool color coming from this light source. Of course, you can make that more pronounced by decreasing the Kelvin on one light and increasing the Kelvin on another. It would produce more blue or more yellow or orange color. So that's the usefulness of this white point value. It allows you to quickly go in and adjust how much color. If you want to balance towards one specific light color, you can do that with this white point. The vignetting option here, what that does is darken the edges, kind of like you would see in a photograph where you're zoomed out and you have this well, the vignetting option, which darkens the edges. If I increase this, let me go back into my hardware shaded viewport here, hit 8 to bring up the exposure control options, and as I increase this, you can kind of see it changing in the viewport. It's one of those subtle effects depending on how zoomed in or zoomed out to the scene you are. And I say that because the closer that you get to the objects here, let me just move this out of the way. You can see that the vignetting, let me just set that to 20 and drag this over. As I zoom in, you'll notice that effect get more pronounced until it gets just almost basically dark. I'm just going to render this out and adjust the exposure outside of 3ds Max. So in order to do that, what I want to do is make sure that I'm not using exposure control. So I'll hit 8, and the scene is currently set up for the photographic exposure control. I'm going to change that to none. And for the best results, I want to render this out in a linear format using a floating point frame buffer here. So I just need to make sure that I'm using a floating point 32-bit frame buffer, because I'm going to save the output image. I'm going to save it out as an HDR file. That way I can adjust exposure kind of like I could real time with the exposure preview that I was talking about earlier here. I'll be able to do that. I'm just going to use Photoshop to adjust exposure control. So let me just give this a quick render. Now, as you look at this render, you may think that I've done something wrong, but in reality, all the information is here. The reason that this is just pure white, I haven't rendered the wrong viewport or anything like that. What happens is I'm not using exposure control to help control all of the light data, all of the information in this render. If I right click on this object, you can see the real pixel value here. You're talking 17,268 for red, greens 21,643. There's a lot of range of information in here. So even though it looks overexposed and like basically nothing right now, all the information that I need is in here. The important thing is when I go to save this image, I'm just going to throw it on my desktop here. I want to save this out to a floating point image. I'm just going to save this out to an HDRI file, and I'm just going to call this exposure test. Now, the important thing to note when you're doing this is you want to make sure that you keep this data linear like it is right now. Linear meaning gamma 1.0. So what I want to do is override, make sure that I'm saving this image in a linear data using gamma 1.0, and just click save. And I'm going to use the non-clamped real pixel color channel information. Alright, now that that's saved, I'll just switch over to Photoshop and load that image in. And again, as it loads in, you can see again, it's just a white, looks like a white image with nothing there. However, what I can do is go to the image option here, and as I scroll down through here, mode, you can see that it is a 32-bit image. And if I wanted to make some adjustments to the image here, I could go to the adjustments, and most of these are grayed out when you're working in 32-bit. But what I want to do is put the use this exposure option, and from here I can adjust the exposure similar to what I did in 3ds Max. So as I start bringing this down, you can see there's our color information, there's our data, and it's here in a linear format. And the usefulness of this is that there's no color corrections or things like that being made here. This is all linear. So if you're doing this in a compositing program, you know, like Nuke or Toxic, Combustion, things like that, whatever you're using, you'll want to keep this information linear. So this probably isn't very useful for still images like what I have here, because I could easily just apply tone mapping in 3ds Max. But for animations, you may want to, if you want to have more control over the exposure control over the length of an animation, then you may want to render out to a floating point format like this and adjust your exposure in post, some kind of a post application. But just in Photoshop, of course, I can go in and make gamma corrections or offset, things like that. But that's the general workflow. I just wanted to show that you can render out a floating point image and do your tone mapping in another application. Just want to show how to do that right quick. So I'll just cancel this and close that and get out of Photoshop and go back into 3ds Max. So in 3ds Max, what I want to do is come back in and add exposure control again. This time I believe what I'll do is add the logarithmic exposure control. And let me just bring up the frame buffer again and enable some of these switches for the frame buffer. I'm going to decrease the precision here just so that I can get a little bit of a quicker render time out of this. And if I just give this a quick render, what you'll see is basically the same thing that I had before. We're going to have an over bright image, and the reason for that is that by default on the logarithmic exposure control, let me just cancel this rendering, you'll notice that you have this option for exterior daylight. Well, this scene is an exterior daylight scene, so what I want to do is enable that. And as you can see, it's now more exposed, properly exposed in the viewport. And also when I go to the render this image, I'll just pause this video while this renders. Now, I've noticed some strange behavior when using the logarithmic exposure control in Max 2010. As you can see here, the output is just basically like the previous render where I did not use exposure control, and that I have just a white image here. But I do have exposure control in natures to use. Also, when you're using this logarithmic exposure control, there's a catch with the gamma and this logarithmic exposure control. What happens is the logarithmic exposure control kind of acts like a gamma setting of 2.2. And so if you're using a gamma setting of 2.2, what can happen is you'll either get like some washed out images, or perhaps your textures will be washed out. They won't match what you're supposed to be seeing in your textures. And so you have to be very careful when you're using this logarithmic exposure control if you're using an adjusted gamma setting, because it's quite tricky to set up. Okay, one other option that you have when you're using exposure control with mental ray is that you can use this pseudo color exposure control option. And the usefulness of this is that you can display some color data, some graph data for the amount of reflected or absorbed light, light on surfaces, things like that. So if you notice here in the viewport, you can see this effect going on here in the viewport. And what I need to do first is change the values here, because this is a daylight scene. And the easiest way to set this up is to probably, instead of using the mental ray sky, if I scroll down here under the sky model, if I use something like this Perez all-weather sky, you can see that I'm given the diffuse horizon and the direct normal illuminance values, and right now these are set up for 929.03 foot candles by default. So if I wanted to set that as my range, that's an easy way to get the range. Whereas if you're using the default, this haze driven sky, you're not really sure of the values that you need to plug into there. So I'm going to switch over to the Perez all weather. And here for the maximum value, I'll enter in 929.03, and you can see that changes my scale here at the bottom as well. And you can choose as far as the quantity, whether I'm measuring illuminance or luminance. Illuminance is, which is the default here, displays the values of light incident on surfaces, whereas illuminance displays the values of light reflected off of surfaces. So I'm just going to leave it on luminance right now, and you have a couple of styles to choose from. You can color or grayscale, and the scale you can set it up for either linear or logarithmic. And I'll just set this up. I can leave it, may set that up for a linear scale. I'll just leave it at the default logarithmic for now. And just so that I can get a quicker render out of this, I'm going to come in and turn off Final Gather. You'll probably want to leave this on if you're measuring actual calculations, of course, but just for the video here, I'm going to turn that off just so that I can get some faster render times out of this. And just go ahead and run this through a render, and I'll pause the video while this calculates. So what happens is, once it goes through and does this calculation, it then spits out another image here that has this chart on it and the actual image using this illuminance data. So those are the three options that you have available to you if you're using mental ray, and they're split up here at the bottom. You have the logarithmic, the photographic exposure control, and the pseudo color exposure control. Again, if you're using a newer version, just to recap, if you're using a newer version of 3ds Max and you're looking to just apply tone mapping, exposure control to your scene, I would definitely recommend using this photographic exposure control over the logarithmic exposure control. Now, if you're using the scanline renderer, you have more options up here at the top. You can use this automatic exposure control, you could use the linear exposure control, or the logarithmic exposure control, and this pseudo color exposure control also works with the scanline renderer. And so you have a couple more options if you're using that, but again, I've just used Mental Ray for this particular renderer for this video because generally Mental Ray is a little more advanced than the scanline renderer in some areas, and it seems that more people are migrating towards either Mental Ray or third-party renders such as V-Ray or Brazil, some of these aftermarket renderers like Maxwell, things like that, rather than using the scanline renderer. I know that there are still people that use the scanline renderer because it is so fast on certain aspects of things, but I just wanted to show the exposure control options here available for Mental Ray because some of these other ones, basically the functionality is the same. The concepts are the same for these other ones. So if you're using the scanline renderer, you can apply what I've gone over here to that to these other options as well. And so with that, I'm going to conclude this discussion on exposure control options using 3ds Max Design 2010.